Talk about change y. What would change next? Something you guys have done over and over and over again. Wasn't anything new. We went from there. After that, we started using different ways of writing equations. One of the equations that we used a lot of was point slope. Point slope form was the working format of slope intercept. Okay. So what we did here is once we found if we had 2 points, we find the slope, then we would use one of those points to write the equation, and we would solve for y. When we did that, we got y by itself, and all of a sudden it looked like this. So this was our point slope, and this became slope intercept. And then obviously when we graphed things that were in slope intercept form because it's a very easy format. Start at your y-intercept and then just start walking your slopes, either up and right or down and right, depending on what the slope is. Now, the stuff we're going to look at today then, it still utilizes kind of the same stuff, but we're going to be talking about parallel and perpendicular in terms of their slopes. So one of the things we have to remember is how do we know if lines are parallel? How do you know if lines are parallel? Ask around. Somebody will have something to write with. I'm not the person that teaches people things. I have paper. Okay. Parallel lines. Parallel lines they don't touch. They're in the same plane. But the reason that happens is because they have the same slope. Parallel lines. They have the same slope. Right? That's what makes it the same. Right? Again, something you should have remembered or seen at least once or twice in your life. On the other hand, perpendicular lines, they obviously intersect. The slopes with perpendicular, they have what are called opposite reciprocal slopes. What is opposite reciprocal? Remember that? There was a bunch of ways that we said this. Opposite reciprocals, that means opposite signs. Opposite signs look correct. That's all it's saying. That's all it's a fancy way of saying it. So a lot of things that will happen is identify parallel or perpendicular, and then rewrite it. Kind of the same. It's nice. See. So what I like to do a lot of times with these, as far as setups and when you look at them and try to make it really easy on yourself, that I always want to try and start with figuring out what the slope is. For example, if I have, I like to use this terminology a lot. My original slope is 2/3. And I'll write it like that. The original slope is 2/3. What's parallel to 2/3? 2/3. You're not wrong. You know what I'm saying? It's the same thing. I know you're going with that, but it's the same thing. So what we'll do is we'll ask questions. If you have an original slope of that, what's parallel to 2/3? 2/3. What's perpendicular to 2/3? Change the sign. Flip the direction. Does that vaguely ring a bell? lot of times what people mess up will be when they're just regular old boring integers. For example, if I have an original slope of -3, what's parallel to -3? -3. Kind of easy. But what's perpendicular to negative? Very good. So what I get at sometimes here when we're trying to talk about perpendicular to -3, change the sign. When you flip, if it's just a 3, what's it over the C? Sometimes people forget that. So when you flip an integer, want to make sure you saw that. Also goes in line with this as well. Remember when we did horizontal and vertical lines last week? Talked about those a lot. When we talked about horizontal lines, what was the slope of every horizontal line? 0. Slope of every horizontal line was 0. What's the slope of every vertical? That's your undefined. Okay. 0 and undefined are opposite reciprocal. Okay? They're opposite reciprocal. Because if you put 0 as a fraction, it's 0 over some number. It is 0 over some. If I flip this, it becomes some number over 0. And can you divide by 0? So that tells me that those two are reciprocal. What do you know about relationship horizontal? What are they? Horizontal lines and vertical lines are perpendicular. What was the equation? Yeah, y equals a number, which means what's the equation of every vertical? Process of elimination, you only have 2 letters. Yeah. So horizontal lines, as you go back to it, y equals some number is always perpendicular to x equals some number. What's parallel to horizontal? Horizontal lines. What's parallel to vertical? Vertical lines. Okay, that's kind of, it sounds silly, but that's all it is. So we have to remember that y equals a number is always parallel to any other y equals a number. And then that also means that x equals a number is parallel to every other x equals a number. Okay. The reason why I'm writing it like this is example, a bit of a shortcut. Okay. That's kind of where I So here's what we're going to do. Going along with a lot of this, we're going to start either parallel or perpendicular to a given line through a specific. And I've always done these problems the same way, whether it was geometry or one, honors alpha 2. I always start these problems the exact same way every single time. And I'll show you guys how I do this. Let's say you have the example, write the equation of a line parallel to y equals -2x 6 through the ordered pair -7. Trying to word it with the worksheet. Write the equation of a line parallel to y equals -2x 6 through the point -4 and 7.
So first thing I always do is this. What's the original slope? Good. I always start these questions out the same way, every single time. First step, what's the original slope? And it was -2. Second step is it a parallel slope problem or is it a perpendicular slope problem? Notice I'm spacing those two out. Tell me if I had to write something. Here's the reason why I do this. The wording is always going to be the same. It's just sometimes it's going to say parallel, sometimes it'll say perpendicular. What'll happen is you'll do two problems of parallel in a row, and you're going to think the third problem is also parallel, but the word actually said perpendicular. This forces you to go back and reread the question. That's the only reason why I do this step. It slows you down and just makes you double check your work. Because there are many times people just, oh, it's the same thing over again. Not really. Because Lord knows you've never screwed up on instructions or something. Ever. Ever. Right? Ever. So is this a parallel or perpendicular problem? Parallel. What's parallel? -2. There you go. So I fill it in. Okay. No problem. It's -2. I know I have to use that. And then lastly, I just use point slope. I mean, use point slope right off of that because I have a point and a slope. And I fill in the blanks. Yep. Yep. So it was y -7 is -2. And instead of writing x minus or -4, what do I write? +1. And then I just solve that. Just like we have. Distribute. And then how do I move the negative stuff? Negative y equals -2x. Like I said, steps. Super easy. Parallel slope problem. Was it a perpendicular? And when I say solve for y, that means we're getting slope. That's what they a lot of times they will word it out. Write the equation and slope intercept formula line that is parallel. So, follow the steps. Makes everything so much easier. Harder to screw up. See, then you could. Sorry. But sorry. I will pause. Just hit him in the head and tell him done. What happens with I try to same idea. Write the equation in the line that is parallel to the point. Write the line that is parallel through the point -6. Again, we're just going to go through all the steps real fast. We'll do a couple perpendiculars, a couple other ones. We'll go from there. So what's your first step? Sorry. I take notes on this. So my original slope here is what? 2/3. Good. Original slope, 2/3. Is it a parallel slope or is it a perpendicular? Okay, what's parallel to 2/3? Thirds. It'll tell you. Like literally, will tell you write the equation line that is parallel to this, or write the equation line that is perpendicular to this. Then upside down. Point slope. What was it? -6, -2. So instead of writing minus and -2, what do I write? Plus 2. So I have y plus 2 equals 2/3. Minus a -6 is +6. And then we come and distribute. Distribute out, let's see, 2/3 times x, 2 6, 4 if I'm not mistaken. And then what do I do? Bring it over. Very systematic, very not much. I'm trying to take away word that follow. That's you can't. Let's try one that's perfect. What's that? Yeah, you got change the slope. So let's say we have y 3x minus 4. That would be perpendicular through your negative 6. Again, it'll have the symbol, or it'll say the word perpendicular. Sometimes if I'm typing it, sometimes I just might type for abbreviation, things like that. And we go through the process the exact same way. Step number 1. Pour forward your French. What is the original slope? 3. Good. Okay. Is this a parallel slope problem or is this a perpendicular slope problem? It's perpendicular. Good. What's perpendicular to a slope of 3? Negative 1/3. Change the sign, flip the fraction. And then I go to point slope. Let's see here. Y minus 6, I believe. Equals negative 1/3 when it's x plus 9. What's the third of 9? So as you distribute out, so y minus 6, negative 1/3 x minus 3. And 6, you get, what's that? Yeah. Don't freak out with fractions or anything, guys. The calculator with the fraction software, you know, super excited. Super excited. It's something. Take a second. Do that one. I know. What was your original slope? 5. Okay. Stay away from decimals. Use fractions. Use fractions. We'll figure it out. You can't walk as decimals. We can change them to fractions. Is this a parallel or a perpendicular problem? Perpendicular. What's perpendicular to a slope of 5? Good. Negative 1/5, guys. Point slope. You know the reason why I keep writing it out? The way you keep writing it out. The more you write it out, the more you'll remember it. Bill, this is no. Sorry. Let's see. Y plus 5 equals negative 1/5 x plus 1. Yes, sir. The setup for doing the problem itself is all the same. It's just when you have perpendicular, you have opposite reciprocal. That's the only difference. You just have, it forces you to read it. Do you have to do a parallel slope or a perpendicular slope? Yes, sir. But then you. What do you mean? Oh, and that's the whole thing using that for. That's why we have the on the slope forms. You use that one over and over. So even though you get a little worried about fractions here, when you multiply fractions, you're just multiplying straight across. So when you distribute, you're going to get y plus 5 equals negative 1/5 x minus 1/5. Okay. You have that multi-do calculator. You type in negative 1/5 minus 5, it does the work for you. Right. You get y equals negative 1/5 x minus 26 over 5. Negative 5 point, that is the same thing. But all you had to do is leave it as a fraction. Wait. No, they're not. No. Trust me on this one. Trust me on this one. You said it was 5.2, and I say it's 6 over 5, right? All right. You multiply this one by 5. I multiply this one by 5. Let's see who gets done first. But you know what I mean. It's, working with fractions is so much easier. I know. And that's great. You got the number sense. That's awesome. I'm just saying that you have to trust me on this one. That the more practice you get with fractions, and just multiplying or just pressing the buttons, next may not be so much for this year. But believe me, when you get into algebra 2 and you're working with this stuff, whatever, there's 4 lines here. But anyway, you've got when you start working in algebra 2, you're going to start adding things 6 quarters, thirds, half. We don't deal with those. I know that if this is 1/6 up, this is 1/6 up. If I go all the way around, it's 2 pi. So this is 1 pi. So what's 1/6 less than a whole? Yeah. What's 1/6 less than a whole? 5/6. You're going to want to know fractions. Trust me on this one. Trust me. Okay. Fractions are so much easier because that's what everybody else uses. All right, let's do another one. Let's say you have this. So write the equation of the line that is parallel to x equals -7/4. What's that? Well, here's the thing. This is the kind that you have to start. Okay, x equals a number is what kind of a line? I know you're about to. Which is horizontal or vertical. What kind of lines are parallel to lines? What's the equation of every single vertical line? If you only had it written down, you could read x equals a number, right? What is x equal in that ordered pair? Ordered pair. That's your answer. Again, what kind of line is x equal a number? Vertical. Every single vertical line is parallel to every other vertical line. What's the equation of every single vertical line? X equals a number. What is x equal? Nothing. Because what happens here, start thinking about it, this point -7/4 is just here. The vertical line that goes through it is x equals 7. The -7, that ordered pair, this tells you it's two dimensions. In order to have a spot to go through, you have to know a location. The x-y coordinate. Does that make sense? What you're asking about? Same thing goes for this. If I have y equals 3, and I want to be perpendicular, or I'll do a parallel to the point of -7 and -4. What kind of line is y equals 3? Horizontal. What kind of lines are parallel to horizontal lines? Other horizontal lines. It's the equation of x equals y equals a number. What is y equal? I don't compare. Okay. What about this thing? This like we were doing earlier. Write the equation of the line. Start that. Remember, write the equation of the line that starts here. Same basic idea. Write the equation of the line that is perpendicular to x equals 2 that goes to the ordered pair of 1, 3. What? What's the equation? You can't just say 3. That'd be y. Okay. Again, what kind of line is x equal a number? Vertical. But so now every line that's vertical, x equals a number. What's perpendicular to every vertical line? Every horizontal line. Every horizontal line has an equation y equals a number. What's y equal to? The answer is. Those are the ones that you guys will all get wrong. They're the easiest. You will all get those wrong because you will over. I'm trying not to, but I'm trying to also tell you where you're going to screw up. So make sure you double check that and maybe have the whole idea of parallels and perpendiculars written down. It would be a good idea. Homework's in the textbook. I think it's like eight problems. Nothing. Pretty sure. 11 through 14 is 5. 19 through 21 is 3. So 8 plus 5 is. I'm sorry, 3 plus 5 is. is hard, you know. I never said I was good at it. I'm good at presenting material. I didn't say I had to be good at this. Yeah. I'm good at corralling a room. I'm loud. People kind of listen to me sometimes. Ish. So, uh, screenshot. Make sure you guys screenshot the Chromebook now before you lose internet. You go home.